So here's our finished graphical to-do list app, built using Python and Tkinter. As soon as the window opens, you'll see our title at the top, To-Do List. Just below that, we have our input area. On the left, there's a text box where we can type a task, and on the right, there's the Add Task button. In the middle, we've got this list area which is currently empty, since we haven't added anything yet. And at the bottom, we have our three buttons, Mark as Done, Delete Task, and Clear All, along with a small status message area. So let's start by adding a few tasks. In the text box, I'll type Study Python and then click on Add Task. You'll notice that it immediately appears in the list with a cross mark at the end, which means the task is not done yet. Our little status label also shows a message saying that the task has been added. Now I'll add a second one. I'll type Go for a Walk, click Add Task, and it shows up as the second item in the list. And let's add one more. Read a book. And again, click Add Task. So now we have three tasks listed, each with a cross mark, showing they're all pending. Next, let's mark one of them as done. I'll click on Go for a Walk in the list to select it, and then click on the Mark as Done button. You'll see that the cross mark for that task changes to a check mark, and our info label updates to say Task marked as done. So now, visually, we can see which tasks are completed and which ones are still pending. Now let's delete a task. This time, I'll select Read a Book from the list, and then click on the Delete Task button. That task disappears from the list, and the status message at the bottom shows something like Delete a task, read a book. So the delete functionality is working exactly as expected. Just to quickly show what happens if we don't select anything, if I click on Mark as Done or Delete Task without selecting a task first, the app will show a small pop-up saying, Please select a task first. It just makes the app a bit more user-friendly.
All right, let's start building our to-do list application using Python and Tkinter, and we'll go through it step by step. So first, we import the modules that we'll need. We import Tkinter as TK. Tkinter is Python's built-in library for creating graphical interface applications, things like windows, buttons, labels, entry fields, and so on. By importing it as TK, we can write shorter code later. Next, we import the message box from Tkinter. This message box is going to be used later to show small pop-up dialogues. For example, when we click on Clear All and we want to confirm with the user if they really want to delete all the tasks. So imports are done. Now we'll wrap our entire GUI app inside a class. Now we create a class called To-Do App. This class is going to hold everything: the main window, all of our widgets, the list of tasks, and all the functions to add, mark, and delete tasks. Keeping everything inside a class makes the code more organized and easier to manage. Inside this class, we have our init method. This is the constructor of the class. It automatically runs when we create an object from this class. We pass root as a parameter here. Root is going to be our main application window, and we'll create it at the bottom of the file. Now inside the init method, we start configuring our main window. So first, we set self.root equal to root. What we're doing here is simply storing that root window object inside the class so we can use self.root anywhere else in this class. This way, whenever we want to add widgets or change something on the window, we always have a reference to it. Next, we give our window a title using self.root.title. Whatever text we pass here will show up in the title bar of the application window. So here we're setting it to To-Do List. You can change this to anything you like. Now we set the size of our window using the geometry method. Here we pass the string values, which means we want the window to be 500 pixels wide and 450 pixels tall. This gives us enough space for our input, the task list, and the control buttons without making the window too big. After that, we call the resizable method and pass false, false. This disables resizing in both directions, horizontal and vertical, so the user won't be able to drag the edges of the window to resize it. We do this to keep the layout fixed so that our widgets don't get stretched or squished if someone resizes the window. Then we use the configure method to set the background color of the window. We pass bg equal to the hex color. This gives us a light grayish blue background, which looks a lot cleaner and softer than the default Tkinter gray. Now we create a list called self.tasks. This is where we're going to store all of our to-do items. Each task will be stored as a small dictionary with the task text and a done status. For now, we just start with an empty list. And finally, at the end of the init method, we call self.setupUI. This method is going to build our entire user interface, the labels, the entry field, the list box, and the buttons. We keep this in a separate method so that our constructor stays clean and easy to read. So with this, our base setup is ready. We've got a window with a title, a fixed size, a background color, and a place to store tasks, and we're ready to start designing the actual UI.
All right, now we're defining a method called setupUI. This method is going to build the actual visual layout of our app, everything the user sees and interacts with. So the first thing we add to the screen is the main title of our app. We're creating a label using tk.label, and we pass in self.root so that this label belongs to the main window. We then set the text to To-Do List, which is the heading of our application. Next, we set the font so the title stands out nicely and feels clean and modern. Then we match the background color to the main window using the same hex color. This makes the title blend in visually rather than looking like a separate floating box. And finally, we set the text color to a dark gray so that it's easy to read. Once the label is configured, we call the pack method and we pass in pad_y equal to 10. This places the label at the top with a little bit of spacing below it so it doesn't stick to the next widget. Next, we'll create an input section where the user can type a task and then add it. So now we create a frame using tk.frame. And again, we pass in self.root so it gets placed inside the main window. We also set the background color to the same color as the window so everything feels consistent. Then we call pack on this frame with pad_y equal to 10 so there's some vertical spacing before and after it. Inside this frame, we add a text entry box. We create an entry widget and store it in self.taskEntry because we'll need to access its content later when the user types something. We set the font to size 12 and we set the width to 30 characters, so the text box is long enough for typical task descriptions. Then we pack this entry widget to the left side of the frame. We also add some horizontal padding on the right using pad_x just to give some breathing room before the button that comes next. Now we add the Add Task button. So we create a button using tk.button and place it inside the same input frame so the entry and button sit side by side in a single row. We set the text to Add Task so it's clear what this button does. We give it a bold font and we set the background to a shade of green. This gives it a positive, action-like feel. We set the text color to white so the button stands out clearly. We also add inner padding using pad_x equal to 10 so the button feels more clickable and balanced. And finally, the command part is important. We set command equal to self.addTask. This tells the button what to do when it's clicked. It will run the addTask method, which we'll write later. Then we pack this button to the left of the input frame so it sits right next to the text entry field. So now the top part of our UI is ready. We have a clean title, a text field where the user can type a new task, and a button to add that task to the list. Now that we have our input area ready, the next thing we're going to set up is the space where all the tasks will appear. So first, we will create a frame. Now, a frame is like a container. It helps us group widgets together and organize the layout. We pass self.root, so this frame gets placed inside the main window. And again, we use the same background color so it blends in nicely with the rest of the interface. Now we call pack on this frame and we set pad_y equal to 10 so there's a little spacing above and below it. We also pass fill equal to both and expand equal to true. This allows the frame to stretch and take up available space, especially vertically, which is useful because this area will contain the scrolling task list. Inside this frame, we add a list box, and we store this in self.taskListBox. Now, this will go into display all of our tasks. We set the font to size 12, and we give it a width of 45 characters and a height of 10 lines, so it looks like a proper list section. We also set active style to none, which removes the default highlighting style and makes the selected line look cleaner. Then we pack this list box to the left side of the frame, and again allow it to expand and stretch using fill equal to both and expand equal to true. This makes sure the list box grows nicely along with the window size constraints, rather than staying small. Now, since task lists can grow long, we'll attach a scroll bar. So we create a scroll bar using tk.scrollbar and place it in the same frame. We pack it on the right side and we set fill to Y.
so the scroll bar stretches vertically along the entire height of the list box. Next, we connect the scroll bar and the list box together using .config. We set the yscroll command of the list box to scrollbar.set. This allows the scroll bar to update its position based on scrolling in the list. And then we set the command of the scroll bar to self.tasklistbox.yview. This tells the list box to scroll when the scroll bar is moved. So now our task list is fully scrollable, which means even if someone adds 20 or 50 tasks, the interface stays clean and easy to navigate. Finally, we'll add a small text area under the list, and we'll use this as a status message. So we create a label and store it in self.info label. We pass self.root because this label belongs directly under the main window, not inside the list frame. We leave the text empty for now because we'll update this dynamically as the user interacts with the app. For example, showing messages like task added or task marked as done. We set the font to size 11, keep the background matching the window, and use a blue text color. Then we pack this label with pad Y, giving it just a little bit of spacing so it sits nicely under the task list. So now the middle part of the interface is ready. We have a scrollable list to display tasks and a status label to give feedback to the user when actions happen. Now we'll build the bottom section of our app, the action buttons that let the user manage their tasks. So first, we create another frame and store it in button frame variable. We pass self.root, so this frame is placed inside the main window, just like the others. We set the background color to the same light grayish blue, so it blends in with the rest of the app. Then we call the pack method on this frame and set pad Y equal to pen. This adds some vertical spacing so the buttons don't sit too close to the list above them. Inside this button frame, we start by creating the Mark as Done button. We use tk.button and set button frame as the parent, so this button stays inside that bottom section. We set the text to Mark as Done, which clearly explains what this button will do. We give it a font size of 11 and make it bold so it stands out. For the background, we use a nice blue color, and we set the text color to white so it's easy to read. We also add some internal padding using pad X equal to 10 so the button is wide enough. Now, the important part is the command. We set command equal to self.markDone. This means that when the user clicks this button, it will call the markDone method, where we'll write the logic to mark the selected task as completed. Finally, we pack this button inside the frame, and we set side equal to left so it aligns to the left. We also add pad X equal to 5, so there's a bit of spacing between this button and the next one. Next, we add the delete task button. Again, we create a button, place it in the button frame, and set the text to delete task. We keep the same font style, size 11 and bold, so all the buttons look consistent. This time, we set the background color to a red shade. This visually tells the user that this button performs a destructive action, like removing something. We keep the text color white and again add pad X equal to 10 to give the button a comfortable width. For the command, we set it to self.deleteTask. So when this button is clicked, it will call the delete task method, which will handle removing the selected task from the list. We pack this button to the left as well and give it pad X equal to 5 so it doesn't touch the other buttons. Finally, we add the Clear All button. We create another button. The font is kept the same so all the buttons look consistent. This time, we set the background color to a gray tone. We keep the text color white and again add pad X equal to 10 so the button doesn't look too thin. We set the command to self.clearAll. So when the user clicks this button, it will call the clearAll method, which will handle asking for confirmation and then clearing all tasks if the user agrees. And then we pack this button to the left with pad X equal to 5 to keep a little spacing between all three buttons. So now our entire user interface is complete. We have a title at the top, an input area with a text field and an add task button, a scrollable list to display all tasks, a status label to show feedback, and 3 action buttons to mark tasks as done, delete a single task, and clear everything. In the next part, we'll start wiring up the logic behind these buttons, things like actually adding tasks to the list, updating the display, and handling selection. So now we're creating a method called refresh listbox.
This method is going to keep our visual list in sync with our actual data, the self.tasks list. Whenever we add, delete, or update a task, we'll call this method so the list box on the screen always shows the latest date. So the first thing we do inside this method is call self.tasklistbox.delete, and we pass 0,tk.end. This basically clears the entire list box. It removes every single row that's currently being displayed. We do this so we can redraw the list from scratch based on whatever is currently inside self.tasks. Next, we loop over self.tasks using the enumerate function, and we start the index from 1. This gives us a nice 1-based numbering for the user. Inside the loop, for each task, we get both the index and the task dictionary. Now we create a variable called status. And if task done is true, we set status to the checkmark emoji. This means the task is completed. Otherwise, we set status to the cross mark emoji, which means the task is still pending. Then we build a string called displayText using an @string. This string looks something like: we include the index, the actual task text, and the status in square brackets. Once we have this display text ready, we insert it into the list box by calling self.tasklistbox.insert, and we pass tk.end and the display text. This adds each task as a new line at the bottom of the list box. So in summary, this refresh listbox method clears the list, then re-adds every task with its number and an emoji showing whether it's done or not. Now we'll create the add task method. This is the method that runs when we click on the Add Task button. So first we get whatever the user has typed in the entry box. We do that by calling self.taskentry.get, and then we call strip on it. Strip just removes any extra spaces from the beginning and the end. So if the user accidentally adds spaces, we don't treat that as a separate task. We store this cleaned up text in a variable called task text. Now we check if task text is empty. If the user hasn't typed anything or just typed spaces, task_text will be an empty string. In that case, we update our info label and set the text to please enter a task first. And then we return from the method so we don't add anything to the list. If we do have some actual text, that means the user has typed a valid task. So now we append a new dictionary to self.tasks. This dictionary has two keys: task, which stores the text of the task, and done, which we set to false, because this is a new task and it's not completed yet. Next, we clear the entry box so it's ready for the next input. We do that by calling self.taskentry.delete, and we pass 0,tk.end. This removes everything from the entry widget. Then we update the info label and set it to something like task study Python added. This is just a small confirmation for the user that their task has actually been added. And finally, we call self.refreshlistbox. This will rebuild the list box and show the new task along with all the existing ones, each with the appropriate icon. So with these two methods, we now have the ability to add new tasks and display the full list in a clean, updated way.
All right, now we'll create a small helper method that will tell us which task the user has selected from the list. So we define a method called getSelectedIndex. Inside this method, we call curSelection on self.tasklistbox. This returns a tuple of selected indices. If the user has clicked on a task, this tuple will contain its index. If they haven't selected anything, the tuple will be empty. So we store this in a variable called selection. Now, we check if the selection is empty. If there is nothing selected, we show a small pop-up message using the messagebox.showInfo. We give it a title like no selection and a message that says, please select a task first. After showing this message, we return none from the method, which means there's no valid selection to work with. If the selection is not empty, that means the user has selected something in the list. In that case, we simply return the first selected index. This index corresponds directly to the position of that task in self.tasks. So this helper method will be used by all our other functions that need to operate on a specific task, like marking it done or deleting it. Now we'll create the method to mark a task as completed. We define a method called markDone. Inside this method, the first thing we do is call self.getSelectedIndex, and we store the result in a variable called index. If index comes back as none, that means the user didn't select anything, and the helper has already shown a message. So in that case, we just return and don't do anything else. If we do have a valid index, that means we know exactly which task the user has highlighted. So now we go to self.tasksIndex, and we set its done field to true. That means this task is now considered completed. Then we update the info label and set the text to task marked as done. This gives immediate feedback to the user that their action was successful. And finally, we call self.refresh listbox. This will rebuild the list display and show a check icon next to the task that we just marked as done. Next, we'll handle deleting a single task from the list. So we define a method called deleteTask. Again, we start by getting the selected index using self.getSelectedIndex. If index is none, we simply return. There's nothing to delete because no task was selected. If we do get a valid index, we call pop on self.tasks with that index and store the result in a variable called removed. The pop method removes that task from the list and also returns it, so we can still access its text. Now we update the info label and show a message like deleted task. We do that by using the removed inside the f string. Then, just like before, we call self.refresh listbox so the updated list without the deleted task appears on the screen. Finally, we'll handle clearing all tasks at once. So we define a method called clearAll. Here, the first thing we do is check if self.tasks is empty. If there are no tasks in the list, we simply update the info label and set the text to no tasks to clear. Then we return because there's nothing more to do. If there are tasks in the list, we ask the user for confirmation before deleting everything. We do that using the messagebox.askYesNo. We pass a title like clear all and a message such as, are you sure you want to delete all tasks? This will show a yes-no dialog to the user, and it returns true if they click yes. So we wrap this in an if condition. If the user clicks yes, we call self.tasks.clear, which removes every task from the list. Then we call self.refresh listbox so the task display becomes completely empty. And finally, we update the info label and set it to all tasks cleared to confirm the action. If the user clicks no in the dialog, the condition fails and nothing is changed. So with these methods, we've now added full control over our tasks. We can detect which task is selected, we can mark tasks as done, we can delete specific tasks, and we can clear the entire list with a confirmation. And now, all we need to do is to create the main window, create an instance of our app, and start the Tkinter main loop.
All right, now we've written all the logic and the user interface inside our class. The last thing we need to do is actually launch the application. So here we write if thundername to dunder main. Now this line might look a bit strange if you're new to Python, but it's a very common pattern. I have already made one video on this in which I have explained what it means and what it does in detail. So if you don't know what it does, you can watch that video. What this line is basically saying is, only run the code inside this block if this file is being run directly as a script and not when it's being imported from somewhere else. So if you open this file and run it with Python, this condition will be true and the code inside will execute. If someone imports this file into another program, this part won't run automatically, which is exactly what we want. Inside this block, the first thing we do is create the main Tkinter window. So we write root equal to tk.tk. This creates a new Tkinter window object and stores it in the variable root. This is the same root that we passed into our class earlier. Next, we create an instance of our To-Do app class. So we write app equal To-Do app of the root. This calls the init method of our class and passes in the root window. Inside that init method, we set up the window, configure the size and background, initialize the tasks list, and call setup UI to build all the widgets we talked about, the title, entry box, list box, buttons, and so on. So after this line runs, our entire interface is ready and wired up, but the window is not running yet. Finally, we have root.mainLoop. This line is what actually starts the Tkinter event loop. Once this runs, Python hands over control to Tkinter, and now the window stays open on the screen, waiting for the user to interact with it. Things like clicking buttons, selecting tasks, closing the window, and so on. Without main loop, the program would just open and immediately close, and we wouldn't see anything. And that's it. Now we've walked through every single part of our to-do list graphical interface app. We set up the main window and styling, built the input area and buttons, created a scrollable list to show tasks, wired up the logic to add tasks, mark them as done, delete them, and clear the entire list, and finally, we started the application with the Tkinter main loop.